Today we will be multiplying binomials again. However, they call this section special products because something specific happens with all of these as we go ahead and multiply them. So let's see what that rule is. Let's take a look at the first one here. When we see a binomial and it's being squared, the common mistake is this. People square both terms. They might get an x squared and a 4, but that's not right, so you don't want to make that mistake. So what you want to do is you want to write out the two binomials that you have being multiplied, because that's what the squared symbol means. It means we're taking this expression inside the parentheses and multiplying it. Well, if we have two binomials, we use the FOIL method. So we're going to multiply those first terms. X and x make an x squared. And then we multiply the outside terms, so x times by 2. And so that gives me a 2x. Then we move on to the inner terms. And so that's the 2 times the x. And then the last terms, the 2 and the 2, give us 4. And this is the common theme that you're going to end up seeing on these problems, is that when you're dealing with binomials that are being squared, your outside and inside terms will be the same each time. So if those are the same numbers, we end up adding them. So we end up with an x squared. We brought down that x squared. I add these two terms together, I get 4x, and then I bring down this 4. So there it is, x squared plus 4x, gotta get that x in there, plus 4. Let's take a look at the next one. Again, the common mistake people want to make is say it's 9a squared plus 4. They might even say 3a squared plus 4. But that's wrong, because they're not dealing with the outside and inside terms if they do that. So what we have to do is write it out twice and multiply using that FOIL method. So we go ahead and take a look at our first terms. We've got 3a and 3a. Remember, that's 9a squared. Well, then we have the 3 multiplied by the 2. That's a 6a. And now we move on to the inside terms. And we've got a 2 being multiplied by 3a. You see, we get another 6a. And the 2 make a positive 4. So there it is again. This is the common theme that you're going to see when we're dealing with binomials being squared. Those inside and outside terms are exactly the same, so they add together. So we bring down the 9a squared, add those two numbers, that makes 12a, and then bring down the 4. And there's our answer. Alright, let's take a look at the next one. So here, again, we've got a binomial. The difference here is that it looks like it's in a little different order. So we have 8 minus y. It's called ascending order. It's done the same way, though. We're going to multiply the first terms. That makes 64 this time. 8 and negative y make a negative 8y. Get that 8 in there, squeeze it in there. And then we also move on to the inside terms, multiply those. We got y and 8. Well, that's a negative y and 8, so it makes another negative 8y. And then negative y and negative y, we finally get a positive y squared. So again, as you see, and as we've seen in the last two problems, our outside and inside terms are always the same. That's why they call these special products, is that there's something specific that's the same with these each time. And when we're dealing with binomials being squared, it's that the outer and inner terms will always be the same. So we have that 64 minus 16y plus y squared. Well, in the next problem here, similar situation. We have the coefficient last, that term with the coefficient last, and we'll go ahead and rewrite it the way they have. So we've got a 6 minus 3n, and then another 6 minus 3n. So just as before, we do the first terms. So we've got the 6 and the 6 make 36. And then we did the 6 and the negative 3. And those multiply to make negative 18n. When we move on past that, we've got the negative 3 and the 6 make a another negative 18n. That's what we expected to happen because we're dealing with a binomial square. And the last term's been positive every time, and it will always be positive. 9n squared. It's always positive because no matter what the signs are, whether they're both negative or both positive, they always make a positive. So from that point, bring down this 36, collect these two terms. Again, they're the same sign, the same number, so we add them together. That gives us a negative 36n. And then we bring down that 9n squared. And there's our answer. The next problem is called a sum and a difference. I call it that because we have the same numbers, x and 3, but now we have a plus sign for the sum and a minus sign for the difference. It's done the same way, though. X and x, those make x squared. So we're just using FOIL. X and negative 3 makes a negative 3x. Well, once we've done that, we move on to the next term. And we got a 3 times x makes a positive 3x. And the 3 times the negative 3 makes a negative 9. So what you'll notice with these problems is something a little different. These two terms are the same number, but opposite in sign. So whenever they're opposite in sign, they end up canceling out. They make 0. And so that we don't even have to worry about writing down the x term. All we're left with is the x squared and the minus 9. So you just bring those two terms down. And that's why they call this a special product, because whenever you're multiplying a sum and a difference, you should get that to happen. Let's see if it does. Taking a look at the next one, we've got an 8 and an 8, which we'll multiply together. Again, using the FOIL method, that makes 64. Then 8 and negative y make a negative 8y. So now we've multiplied the 8 by each of the terms. So let's move on to those y. So it's y times 8 makes a positive 8y. And a y times negative y makes a negative y squared. So we have the same situation again. See these two terms right here? They are opposite in sign. They will cancel out and they make 0. And so we just bring down whatever's left over. So in this case, we bring down this 64. We bring down this negative y squared. And we've got our answer. There it is, 64 minus y squared. Well, let's try another one. We've got 10x and 10x. Careful on this one. A lot of people want to say 10x or 100x. And 100x would be closer than 10x, but it's still wrong. You see, it's an x times an x makes a 100x squared. So then we do 10x times negative 7y. So multiply the two coefficients. It makes negative 70. And then x times by y just makes xy. Doesn't matter which order, just keep it consistent. Let's take a look at the next one. Moving on to that 7y multiplied by the 10x. So it makes a positive 70. Now yx is the same as xy, so let's just rewrite it the same way we did this one. And then 7y times by negative 7y makes a positive 49y squared. So again, we're going to get the same situation. See these two terms? They're the same numbers, opposite signs, so they cancel out. So we're just left with that 100x squared plus the 49y squared. There's our answer. Well, and one more problem like this. X squared times x squared, using that FOIL method, makes x to the 4th power. Adding up those exponents. You have 2x's and 2x's, make 4. Over here we've got a negative 3x squared y. Typically we write the coefficient first and the variable that comes first in the alphabet. So I did x squared and then the y. Moving on to the 3y, multiply that by the x squared. It gives us a positive 3x squared y. And the 3y times by the negative 3y makes a negative 9y squared. So from that point, all I'm doing is collecting terms. So these two terms right here, same variable exponent combination, opposite signs, they cancel out. So all I'm left with is that x to the 4th minus the 9y squared. And there's our answer. Well, one more problem here. It's an area problem. And so we're trying to find out what the shaded region is. So the best way to do this is break it into parts. We've got our large rectangle, and our rectangle has sides of x, or 6 plus x, and then over here we've got a 6 minus x. And then this piece is being taken away, so we're taking it away. And so that rectangle has a length of 2 plus x and 2 minus x. So we're ready to go ahead and figure out what our answer is. So what we're going to do is we're going to find the area by just doing base times height. So it's just the 6 plus x multiplied by 6 minus x. So we're going to do that first. Then after that, we're going to do the 2 plus x multiplied by the 2 minus x. So let's go check our answers here. We've got 6 times 6 makes that 36. And then 6 times negative x makes a negative 6x. Over here, the 6 times x makes a positive 6x. And the x times the negative x makes a negative x squared. So remember, these two terms are going to cancel because they are opposite in sign. So I'm just left with a 36 minus x squared. Let's see what we're left with on this side. Here we've got the 2 times 2 makes the 4. And the 2 times negative x makes a negative 2x. X and 2 multiply to make 2x. And then over here, x and negative x make a negative x squared. So when we collect these two terms right here, they are the same sign. Well, same number, opposite sign. So we're left with a 4 minus x squared. Now notice that we are subtracting that expression from this expression. So it becomes an addition problem that we want to make. Well, when we do that, whenever we have a minus sign, change it to addition. The two numbers here switch sign. You add the opposite. So now we're ready to solve. So here we go ahead and collect some like terms. Let me rewrite what we've got. 36 minus x squared. And over here we got negative 4 plus x squared. When I add this stuff together, the x squared's canceled out. And I'm left with a 36 minus 4 gives me 32. So there it is. 32 units squared was the answer. Well, those are some of the problems you'll see on the test. Good luck, or on the homework. Good luck.